Okay, so I am Michael Musa. I've been working with PHP for about 14-15 years now. Sometime in the last 4 or 5 years I discovered unit testing, and it's made my workflow and just my general work experience a lot better. I went from working on code, uploading it to production, hoping that it works, and working late and getting calls after hours, to going home at 5 o'clock and not hearing from anybody until the next day at work. Because with tests, the system is going to automatically test your code same way that it's done 100 times. It's not going to forget to check any little thing, and you're going to have a better confidence that the applications that you're working on and push to production are going to work. So key topics that I'm going to go over in this talk is what unit testing is exactly and what the benefits of it are, how to get started. I'll have some basic examples of tests, some examples of mocking, which is a more intermediate component of testing, some ways to get testing metrics, and finally I'll go into testability and actually some tips and tricks and other cool things that you can do with testing. So unit testing is basically an automated way to test portions of your application against a specification. In other words, does the small unit of code that you're testing do what it is expected to do? So you'll be able to write your tests, you run it through a framework, and the framework will do everything. It's completely automated, and you don't have to go in and manually test things. You'll be testing individual methods of a class and how they interact with all their collaborators. And of course, the specification is your definition of how things are supposed to work. So benefits: unit testing will help you prevent regressions. If you make changes to code that breaks existing code, the test will pick it up, and you'll know obviously not to deploy that code. It makes things easier for new developers. Anybody coming into the company brand new and working on an unfamiliar application, they are not going to be able to get settled in for a while after they've been exposed to the code base, but at least with a good test suite, they'll be able to know, oh, is this thing that I'm working on here going to break something, or is everything right? Or if they don't understand how a class works, they can read the test to see how it's supposed to behave. Makes refactoring a lot easier. The test suite is basically a safety net. You see a bunch of code that you want to change because it doesn't work right or it doesn't look good, you can go in, do it, and see if your tests still run. It's a lot more convenient than having to test the entire application by hand to make sure you didn't break something. And finally, it encourages better design. Code that is hard to test is usually not designed well. Code that is designed well will usually be easier to test. So if you find that your code is hard to test, you'll be writing better code to make it easier to test. So getting started, the first thing that we're going to use is a PHP unit. That's basically the biggest PHP testing framework. Pretty much any company that does PHP unit testing uses this testing framework. This is the main site, and this is the GitHub link. Easiest way to install is via Composer. The package is PHP unit/PHP unit. Right now they're on version 4.1. So I've got basic examples of tests, and each example has a corresponding tag in the GitHub repository. I have a link to this GitHub at the beginning of the slide deck, so you'll be able to go there and see all the different tags that I've got for each of the code examples. So we'll start with the first one was slide 5, which was the previous slide where I've already got PHP unit installed. And you see I can run PHP unit, but it's going to say no tests executed because I actually don't have any tests in the code yet. So slide 6.1 is we're going to be looking at the concept of a simple bank account. You deposit money, withdraw money, and this is a class that is going to keep track of all that. So we've got a basic bank account. There's not much going on here. It's just a single public property that has an initial balance of 0. And we have a basic unit test here. We've got our namespace. It's using the PHP unit framework test case. And every unit test class will extend that and end with the word test. And every test will begin with the word test, and usually the function name is what you're testing in camel case. And then you just set up your test. We've got a new bank account and we want to make sure the balance is initially 0. And then if we run our tests, then it won't work because I have to run composer. Oh, okay. There we go. I usually have a PHP unit XML to handle the bootstrapping for me, so I forgot that command. But anyway, so it's going to run the test, and here we get an OK because the initial balance is actually 0. If I were to change this to, say, $10, for example, then the test would fail because the initial value doesn't match what we expect. PHP unit works via functions that are called assertions. And there's several. You can type this assert and look at the list. There are at least 20 or 30, maybe more. And this is basically the things that you're testing. You're testing that one value does not equal another value, testing that something is false, testing that a certain array has a particular count. You can test, if you render HTML, you can check that there's a tag with the ID foobar. And this is the HTML that we have. So there are a ton of these. You can look in the PHP unit manual to get a list of all the assertions. Okay, and then some basic bank account methods. Okay, so here we have we've changed the balance to protected. We have a constructor that we can inject the balance. We have a getter for the balance, a deposit and withdraw method, and then some exceptions that we throw if we get some invalid values. In our tests, we have one test for each of these cases. Typically, you'll want to test just one main idea per test. You don't want to. You can have multiple assertions in one test, but you don't really want to have testing multiple unrelated things in the same test. It just makes a test harder to maintain and doesn't make it obvious what each one is testing. So here, balance initially 0, just default here. We're testing that we can set the balance via the constructor, testing that we can deposit money and then that money is reflected in the balance. Same deal with withdrawing. We have a bank account here with initial value of 100 and we can withdraw from it. And here we're testing our exceptions. We don't want to be able to deposit negative money or withdraw negative money. So whenever this happens, we expect an invalid argument exception, and we expect it with this message. Any questions on the basic examples? No? Okay. So next thing we're going to talk about is mocking. The bank account like that by itself is not terribly useful. It's more useful when we're able to persist the data in a database and have customer information and keep track of all the accounts. So if we have, say, a bank account service that handles all that persistence, it'll take a PDO database connection, and I'll try to persist an account that I'll pass to this persist method. If the account already has an ID, I know it's an existing account, and I will just update the existing account and set the balance accordingly. And if it doesn't have an ID, we know it's a new account, and we'll insert it. So, okay, the test for this is in the next slide. Okay, so here we want to test that when we create a new account, then it's inserted into the database. So I create my bank account service, I pass it a PDO object with the connection to my local database, I deposit some money, I persist that new account, find the account, and then I check and make sure that the balance is correct. So I just fire up my SQL. I'll run the test. There we go. So you run the test, you can run it as many times as you want, and the results will be the same. Now, the problem with doing it this way is that every time I run that test, I'm going to get a new deposit. So what does that mean? This means, let's say we're doing this against a shared database, maybe a QA database or a test database. What happens if another developer runs the tests right after you or runs the tests right before you? You're going to have all this duplicate data. How are you going to clean this up? Well, a few months down the road, we're running these tests all day. The database is going to fill up, so we're going to have to maintain that, prune that. If we're testing on more complex data, we need to make sure that data is already there to begin with. So that makes it a lot more difficult. Maybe you can avoid conflicting with other people by running your tests locally, and no one can connect to your database. But then you're going to have a problem if you want to do any kind of continuous integration, like have a separate server run these tests, because the server won't be able to connect to your computer. So the way that we get around, and of course, connecting to the database is pretty slow. You're opening up a connection over a network, so when you're up to hundreds or thousands of tests are going to run a lot slower. So what we do is we create what are called mock objects. And a mock object is basically an object that mimics the behavior of another real object, but in a way that you can control. So you tell it, all right, I need you to behave in this way while I'm running this test, and then the object will do exactly what you tell it to do. So the mock version of this is this one. The setup is a little bit longer, but it has the advantage of not actually doing anything in the database. If I remove that method that uses the live database, and I remove all the accounts, and I run the test several times, you'll see no new accounts are created here. So the way this works, and we kind of have to go in a strange order to explain this, because we can't just go from the top. The first thing, I know that when I create a bank account service, I need an instance of PDO. So I'm creating a mock for PDO. For the database, I'm telling it, just create an SQLite database in memory. So that's fast versus connecting to an actual MySQL database or creating a database in the file system. And then I get a mock for that. And I know that in my bank account service, since the account does not have an ID, I know that I'm going to call prepare, and I'm going to call it with this SQL statement. So I tell it expect one time to call the method prepare with this SQL, and it's going to return a statement. And that statement I've defined up here. The statement is going to, so the reason I use std class here is because of mocking PDO is tricky, unfortunately, because you can't serialize that class, and the way PHP unit creates mocks without calling the original constructor is by using serialization. So you can't do that for PDO, but fortunately we don't actually need the value that gets returned to really be a PDO statement, so I can just tell it to create a mock of an std class, and that's fine. So I tell it I'm going to call the execute method, and I call the execute method with 500. So now, and it's going to return the ID of the account that just got inserted. So now in my setup, I tell it, all right, you're going to call last insert ID once I'm done, and I want you to return a value of 1. And then you run the test as normal. Bank account, deposit 500, persist, and if this was all set up correctly and the service is calling the right stuff, then it's going to return 1. You see an example of this. If I make any change, like let's say that let's say I remove this. I'm just going to go ahead and update the account, set the balance, where the ID is, whatever. If I run this test, and it's going to complain because the SQL is wrong. It's expecting an insert and I'm doing an update. Okay. And I've created a, for anybody who's not that familiar with mocking, I created a mocking sandbox here where you can just play around and create your own mocks of stuff. Like here I'm mocking the bank account class and mocking the deposit method. And so if I call, or actually I'm calling the deposit method, but then I call get balance and the value is not 100 because I've mocked the deposit method. I haven't told it to actually do anything. So this is just a little sandbox to play around in and get familiar with the concept of mocking. Okay. Any questions on mocking? Anything you want me to go into more detail on?
That thing you talked about where you use the STD class.
Yeah.
So what would you do when you have an actual hint of type hinting?
Okay. So if there's a type hinting, what you can do is you can actually cheat. Let's say that let me find a good example. Where's my service set? There it is. All right, so PDO is type hinted. So what I could do instead is I could do something like that. So you create it's fake PDO. With a constructor that doesn't do anything. So when I create this mock fake PDO, it's not going to call the parent constructor anyway.
What about when the methods that you're trying to bump? That doesn't make sense.
You're saying the method you're injecting it into is type hinted?
Right.
That's the case here. So the service is type hinted. It wants a PDO, and I got around that by just creating the SQLite database in memory, but I could have also gotten around that by creating this fake PDO class and just creating a mock of this instead of right.
And another way to tackle that is in your test, you could just do a setup, and in the setup have it create a mock object using straight PDO. And just say create a PDO memory table, and then type hint that into your test.
Right. So there's
that way you're creating your test in a way that it's taking dependency injection.
Right. So there are two methods. There's setup and there's teardown. And the way this works is before every test that's run, it's going to call the setup method, and after every test that's run, it's going to call the teardown method. So in here is where you would do something like that. If you know that every test in this class is going to need an instance of PDO, you create it here, and you could set it like as a class member, and then you can use it in here, and that'll save you from copying and pasting a whole lot of code.
Then your test can read just the text.
Right.
You're not doing your mock within the test.
Right.
You're doing the mock in the setup, and then you're injecting that. Well, you don't have to inject because it's.
Yeah, you wouldn't inject it, but you just refer to it because it's right there in the class. That's very common with like controller tests if you're writing tests for Zen framework. Any other questions? Okay. So coverage and change risk analysis and predictions, which has the cute acronym CRAP. So to generate code coverage and figure out your program's CRAP score, you need xdebug. Free library instructions are on their site of how to install it. It's fairly straightforward. And let's see, let's clear out all this sample stuff that we did and generate some code coverage. And I forgot to bootstrap again. Sorry about that. I'll show you how to avoid that in the next couple slides.
Have you been using Storm to run your tests, or do you do them on command line?
I do them on the command line just because it's easier for me, and because PHP Storm, if you measure code coverage, it starts changing the colors of your lines in the gutter, and it drives me nuts. So yeah. So I'm running PHP unit. I'm The bootstrap is just telling PHP Unit, okay, I need you to load this PHP file before you do anything, and here I'm just loading composer's autoload so it could find all my classes. Normally you'd use a PHP Unit.xml file, so you don't have to do all this, and I'll show you how that works in a couple slides. And then I'm using the coverage HTML flag, and I'm passing it this directory coverage HTML. That's where I want it to put the code coverage information. So it's going to run, and it's going to skip any tests that I've told it to skip, and it's going to generate the code coverage report. And then you can go into your browser and open that directory and just load index.html, and it's going to show you everything in your project and what's covered by tests and what's not. So if I go into the src directory, I see that every single line in the bank account model class is covered by at least one test. And in the service, the only one that's covered is this portion, but the one for existing accounts is not covered because we haven't written a test for it. So this is a good way to know what areas of your code your different tests are actually touching. And here where it says 2 tests cover line 45, 2 tests cover line 51, this will tell you how many tests are actually running this. So if you have a really complicated method that has several tests running it, you know that you'll probably have better safety, better coverage of that method than if just there's just one test covering it, for example. So here we go. Simplify things with a PHP Unit.xml. So let's check out slide 8.2. And I actually forgot to put the bootstrap here, believe it or not. Whoops. All right, so this is in the test directory, vendor autoload.php. All right, so what I'm saying here is I want PHP Unit to load this bootstrap. I want it to give me colorful output because seeing the green line saying all my tests pass is great. And then I'm telling it that I only want to worry about things in the src directory, because you notice on the first thing it showed me the composer directory and all that. We don't care about any of that, we just care about our code. And then I'm telling it I want you to generate coverage HTML logging to this directory always. So now when I go back to my test, if I just run php unit dot, it's going to do all this. I get this is yellow because it's there's a skip test. And where did I skip that test actually? Ah, here we go, this one. All right, so if I just remove that, then you'll see green. Hooray, everything works. And something fails, you see red. There are a ton of different things that you can put in your PHP Unit.xml. There's the link right here in the appendix to PHP Unit's documentation, and you could also, most of the things that you see in the help, you can put in the PHP Unit.xml, like the logging stuff, the test filter, test groups, all sorts of things like that. Okay, now, the CRAP score, just like this says here, it's a way to analyze and predict the amount of effort, pain, and time is required to maintain an existing body of code. Code with a high CRAP score is hard to maintain, hard to understand. Code with a code with a low CRAP score is not right. This guy's site has a bunch of good examples on it. First, let me show you the example in our code here. We'll see that we've got the bank account class. See, all of our methods are really simple. This one is, we're just setting values. These have a CRAP score of 1, which is the lowest CRAP score that you can get. These are a little more complex because there's a conditional statement. There are 2 paths really that this program could take. It could either go in here and throw in an exception, or it can go here. This one has a CRAP score of 2. Right. It's based on the cyclomatic complexity. And the reference to that is on this site as well. So here, constructor again, simple, but persist method's a little more complicated. It gets a 2.31 because we've got one test here. If I actually were to if I were to remove the tests, run the test suite again, and come back here, oh, it won't generate anything because it doesn't know of this yet. So I'll delete the tests, but not the class. It wants me to test something. There we go. So now, I don't know why it's not generating coverage for that now.
Might be the PHP unit XML. Just pass it through the command line.
Oh, I see what happened. It generated it. The path is different now. There we go. So now the crap score has gone up to 6. The method hasn't changed, but there are fewer tests covering it. Before there was 1, now there's 0. So there's a higher risk of any changes to this method causing some problems because there are no tests covering it. If you add the tests back and run it, then you'll see that we go back down to 2.31. There we go. So this guy's site, he gives a good example here. So this is a method that is just supposed to list the cities that are in a state, and he's just got a bunch of if statements. If this is a state, then do this. If else, if that, and then throw an exception. And then he's got just a simple test here. So the crap score of that is 42 because there's so much different stuff that could go on in here. There's a whole load of different execution paths, and it's just a mess. So if he writes some actual tests for that method, testing, all right, Nebraska will give me Omaha, Lincoln, etc. Iowa will give me this. The crap score goes all the way down to 11. A lot better, but still not good. Test it more completely, goes down even lower, goes down to 6. And finally, simplifying it a little bit more to this. He's just got an array, and it's just going to return whichever array corresponds to the state he's looking for. The score goes all the way down to 2. So something like this would be a lot easier to maintain than something like this. You add a new city, you have to add a new if statement, you have to list all the cities here, you need to add all this stuff in the test versus, oh hey look, we have an array and all the cities are in there. So one way to lower your application scrap score is to add more tests. An easier way is to just write easier to maintain code with less complexity. If you can't make it any simpler, you can split it up, you can do all sorts of things to get it to work better. Any questions on crap score? No? Okay.
No more questions about crap.
All right, testability. In my experience, I've seen a lot of code bases that are difficult to test. You just go in there, you try to write unit tests, and you don't even know where to begin. And there are different things that make code bases like this hard to test. I'm going to list a few of them here and show you some alternatives. One is objects creating their own dependencies. So we've got, all right, so let's say we've got this class here with a constructor. So this first constructor, I start the constructor, I create a PDO, and then I create a bank account service. You can't mock either of these. When you call this constructor, it's always going to create a new PDO, and it's always going to create a new bank account service. There's no way for us to intercept that and inject our own fake so that it'll do what we need it to do during the test. Something better would be something like this, where instead it receives a PDO object, which we can mock out. But even better than that is this one. The only reason that we have a PDO here is so that we can create a bank account service. So cut out the middleman, just ask for a bank account service. We can mock that very easily. and inject it directly, and we don't even have to mess with PDO at all here, because we know we're going to be calling methods on the service. We're not going to be calling methods on PDO. Another way to do this is just using setters. So your constructor wouldn't do anything, and then you can call a setter and say, okay, here's the bank account service, use this. I try to avoid that if I can, because typically if I call a constructor, I expect the class to be usable right after that. I shouldn't need to do anything else to get it running. Sometimes constructors have a really long laundry list of arguments, so you want to create setters so that you don't have really long arguments. But if that's the case, maybe your class is doing a little too much, and you could look into refactoring that. So basically, have your classes ask for what they need. Don't have them go out and look for them. Globals. So let's say we have some random function, process the data. It grabs a global value data, it iterates over it, reverses it, and then bam, some other class is going to use it. This is not ideal, because data that can be set anywhere in the application, anything in the application can change it. And you can run this test, you can set it up perfectly, and then you run your application and it breaks because you just can't predict where this is going to be changed. You can't know the state of the variable in the application when it's running, so you can't really be confident in the test. And if you run into an application error, all your error log is going to say is, okay, there's an error on this line. You can't trace back and find where it came from. A better way would be to pass the value in. Here's the data, do what you need to do to it, and then return it back. The scope is local to here. We know that there's not going to be any spooky action at a distance to this variable. And if you run into an error, your stack trace is going to show you, okay, this method called this one, this one, and then that's when data broke. If you want to use globals, constants, that's fine.
How can you do the test for that?
For which one?
The process that.
So for this one, you'd make an instance of this testability class, and then you would have to, in your test, you would do global data, and then you would define data there, and then you would call the function.
Yeah, but I mean, you have to do the same functionality to see.
Okay, I see what you mean. So if, let's say I'm in my test class right now, so I would do global data.
But not with that one.
With
the
the better one. Oh, okay. This one's even easier. You tell it, let's say value name and array. Okay, so if I have an array, if I'm passing it an array that says name Mike, then I know that it should return name Mike, and then it should have another field called name in reverse, and then it should return Akeem. So what you would do is you would call process the data better with this, and then you would assert that the return value is the same as this, since you know what it's supposed to do. So you wouldn't actually say, okay, name in reverse is string reverse of this. Skip all this. Just you know what it's supposed to come out to. You tell it what it come out to. Okay. So yeah, if you need to use globals, constants are good. They're defined in one place. They can't be changed anywhere, and you'll always know what they are. Stuff like your database connectivity password and paths to stuff, all that is fine. Mutable globals, not. Okay. Static methods. Static methods are pretty much death to testability. It makes it very, very hard. This, let's say I have a class that uses an API. I call this API method, and I have a class called HTTP that handles all of my HTTP requests, and I want to get the contents of this URL and return it. I can't mock this. Every time I run this test, it's going to call this API. If the API is slow, if the API is down, if the API changes, all my tests that use this are going to break, and they're going to be very slow. Same thing here. It's the same thing, but singletons deserve special mention because they're they're very common as a design pattern, but they're really an anti-pattern. They make your code more difficult to test too. Yeah, basically anything that goes external, SOAP, XML, RPC, REST, it's going to go out and do something. You want to avoid that. You want to just have it mocked, because if I'm using an external service, I have to assume that the people who wrote that service knew what they were doing and it works. So I'm not going to concern myself, at least in my unit test, I'm not going to concern myself with testing that. I just want to make sure that my code works. If I'm doing integration tests, where like automated tests that go in and open a browser and try things, then yeah, we expect those to run slower, so it's okay for those to call the external service. But your unit test should be fast. I mean, I should be able to be writing code and running my whole test suite and not even having enough time to stop and think, oh, what's going on here? It should just be very, very fast. I've got my code base for my main project at work is like 200 or 300 tests. It takes like a second or two to run everything. Okay, and singletons, did I actually... Oh, okay, I lumped that into slide 9.3, so I'll update the slides. And classes that do too much. Your classes should really be limited to a single responsibility. So I've got the bank account model that all it does is it keeps track of all the data in all the properties. I have the service object, and then I mean the service object that I have kind of does both the data mapper and the service object. Normally I'd use something like an ORM or have a separate data mapper class that handles all that, as opposed to one class that does all of that. So think, is anybody familiar with Active Record, the design pattern Active Record? So it's your object that has all the values, and it also handles connecting to the database, and it also handles saving. That's hard to test because every time you do something, it's going to talk to the database, so you have to mock that out. No, you got a value object, all it's going to do is set values. That makes it very easy. Okay, testability questions? All right, tips, tricks, and other useful stuff. You don't have to use PHP Unit's mocking library. There are actually a few others out there. There's a XP mock. That one's my favorite. I'll show you why. There's also Mockery. Let's look at XP mock. So if you remember this test where we were mocking out all this stuff, this is using PHP Unit's built-in testing mocking framework. You use XP mock instead, it's become a lot shorter. I'm telling it I want to mock std class, I'm going to call execute with this parameter one time. Bam, give me a new one. Mock PDO, I'm going to call prepare with this, it's going to return statement, I'm going to do that one time, and I'm also going to do this, and then create a new one and pass this to the constructor. That's super, super simple. If you look at their documentation, they'll give you other examples. Right, this, I've mocked out 3 methods versus all of this. It does exactly what the PHP Unit mocking library does, just simplifies it for you. And here it'll show you all the different ways that you would do it in PHP Unit, and then it shows you the equivalent for XP mock, so it's really, really, really easy to use. The other one is Mockery. A lot of people love Mockery. They think it's really powerful. I don't like it because the documentation is like 1,000 pages long and I don't have time to read all that. XP mock, it's 1 page, does everything that I need it to do. But definitely check out Mockery. If anybody has gone through this and read it all and use it, it's because it's probably good. So take a look. We can also run the same tests with different sets of data. So let's say I have a method I have a test for explode. I want to test that if I explode a string, then I get an array based on this delimiter. If I wanted to write 5 or 6 different tests with different types of data that may behave strangely, I could either copy and paste all this several times, or I can use a data provider, where you basically have an annotation data provider, and you tell it what the data provider function is, and then the data provider function returns an array of values. So here I'm telling it the string is foobar, the delimiter is the comma, and when that function is called with these parameters, then it should return this expected value. And same thing here. This time it's pipe separated, and you get this. I could add 5 more arrays, I could add 100 more arrays, and it'll run this test that many times. So let's say I tell it, run my test, but only run the test exploding string. 2 assertions, but I've only got 1 assertion in the function, and that's because it called this test with each of these. This is really handy in, I mean, this would be handy for the persistence one for the accounts, because I could return 2 or 3 different accounts, one with an ID, one without an ID, and then tell it, when you get the one with the ID, I want you to do this. When you get the other one, I want you to do that. If you are lucky enough to be using a PHP version that has traits, you can test those very easily too. Let's say I have my trait here, public foo equals bar, and you just create a class for the test, just an empty class that uses the trait, and then I can run my test. Some trait tester is this, assert that foo is equal to bar. That's because you can't instantiate the trait directly, so you just create a little wrapper class, and that's the one that you test. And the nice thing is you don't have to create a separate file for this trait tester. You can just create it in your same test file. Mocking PHP functions and predicting randomness. I've run into this a few times. I actually got asked about this at work today, and I gave a link to my slides, so that was pretty cool. So let's say that, all right, and I'm using the trait for these test functions because it's convenient. So let's say I have a function, what time is it? And it's going to return the current micro time. And I just want to make sure that when I call what time is it, that's equal to micro time. So I'm calling the same exact function, it should work, right? Mocking. This runs so fast that
it's actually working.
Wow.
It's the SSD.
That's right, I am on an SSD. Oh man.
Should I sleep?
Yeah, okay. Alright, I'm gonna cheat. Oh, am I calling the wrong one?
No, but you called the sleep before. You should. Yeah, you should.
Yeah, you're right. You're right. You're right. I'll do this. Okay. So I worked on my machine at night, last night. Okay. Yeah. Okay, I'll eventually figure out why that happened, but so microtime returns the current time in microseconds. So in theory, if your test takes more than a single microsecond to run, you're going to get a different value, and your test is going to fail. But there's nothing wrong with your code. So, oh, I think I know why. There we go.
Hey.
So now it doesn't work because the test does not run instantaneously. How do I fix that? I create the function that I just deleted. You can, when you use namespaces, if you use an opening curly brace afterward, then everything that's inside of that is going to be local to this namespace. And since some trait also has the same namespace, it's going to actually use my microtime function instead of PHP's. So the reason this was working is because it wasn't returning the microtime, it was just returning it works all the time. When I remove this, then it fails. You can have the same thing with let's say you have something that loads a do I have the message of the day example here? No. Let's say you have a function that loads the quote of the day or whatever, and the quote of the day is stored in a file. If you don't want to be going to the file system every time and reading the quote of the day, or if you don't want to update your test every time the quote of the day changes, mock out file get contents, and boom, it works. If you need to call the actual PHP version of that function, you can use the / or the backslash, and that'll give you the global version. That's what I was asked about today. Someone said, I need to mock out, I think it was file get contents, or no, file put contents. I need to mock out file put contents, but only for one of my tests, not for all of them. So I told them, all right, you just use a different file name and have it do, if file name is this, then do the mocked version. Otherwise, call the global version, and then it'll work exactly the same. Yeah, sorry I forgot I put that here. That made that example a little weird. And predicting randomness. Let's say you have code that does random stuff, and you want to make sure it works. This is going to generate a random number between 1 and 100, but I'm always testing that it's 7. Why? I've cheated. I seeded the random number generator. So now I know every time that rand gets called, 7 is going to be the very first value that gets generated if I pass these parameters. This is really useful if you're, I mean, rand is not appropriate for cryptographic use or anything like that, but for instance, if you were doing something like that and you wanted to make sure that you would always get that same value when you ran the encryption function, you would seed the random number generator.
I'm going to tell Anthony Ferrara what you're
Well, I'm recording this, and on the record, I'm telling you, don't use rand from cryptography. So, okay, and last cool trick, test-driven development. Write the test before you write the code. So, if I'm writing a function to add 2 numbers, I can just go in here, function test, add 2 numbers. Some trait tester, here's some trait. So there, I've written the test. It's going to fail if I run all the tests. It's going to fail because the method doesn't exist. I go in. Oops, I pushed the wrong button. I run my test. It's going to fail. I go back in. Oh, it's because I put a minus instead of a plus. I put my plus. Bam, test works. This is a lot easier than going into your browser, refreshing, clicking the button. Oh, it doesn't work. Let me go back to my test. No, write the test first. As you're writing the code, run your test. Once you see everything passes, then go into your browser, give it a final once-over. Okay, bam, I'm done, and then deploy. This is also good for design reasons. If you're writing a function, by the time you get to the end of the function, you decide, okay, let me write my test now. Oh, wait, I wrote this in such a way that's a nightmare to test. If you're writing the test first, you're already thinking, all right, how can I make this easy to test? I'm injecting this dependency. I'm not doing all this complicated stuff. I'm not putting too much in the same method. That makes it a lot easier. I experienced this firsthand at my last job. We actually required, I think it was like 90–95% code coverage on our unit tests, except in controllers. In controllers, we only required 35%. Why did we require 35%? Because our controllers were hard to test. Why were they hard to test? Because we only required 35%. If we required 90%, we would have made them a lot easier to test, and then we wouldn't have had to have such a low threshold. So write your tests first, make your life a lot easier. PHP unit, I showed you the help already. Run that, and you'll see all the different commands you can do. This is the link to the PHP unit manual. Super detailed, and this is actually new. I haven't seen this before. There's a link on the PHP unit website for a whole bunch of different presentations on unit testing with all sorts of examples. You can just sit there and watch testing to your heart's content. Any questions?
If I want to run a task that I want to fail, not always I want to good or get a good thing.
You wanna check that the test fails, or you want to check that the function you're testing
it fails to be sure. Imagine that I want to return a microtime thing, and it returns data. I want to test that. What happens if I give a date?
So you want to test that the code fails, which it should.
Right. Okay. So in here, Oh, like the okay, I see
No,
that.
well, I don't know if like.
Well, no, that one will work. That one will work for this. Where did I put that? That was in. Is it in here? Yeah, here. Test exploding string. Okay, so you wanted to test that if you call this with how?
Put another delimiter.
Okay, all right. So let's say that instead of using the delimiter that I pass in, I use the @ something like that. So if I run that, it's going to fail because for the first time that it ran with the first data set, I told it to use the comma, and it didn't split anything because it couldn't find the ampersand, the @ sign delimiter.
So you put a not at the beginning of the assert, and then it would succeed, which is what she's asking.
Okay, yeah. So assert not same.
Most of the assertions have a negative to them, or if you know that if your function is going to fail and throw an exception, then you can expect to have an exception.
Do I have some unanswered for exceptions?
Yeah,
There's a few, yeah.
It's in here in the bank account test. Test exception is thrown when depositing negative money. So I go to deposit negative money. I'm telling it expect this exception to be thrown and expect the message to say this. And if you go in here, you see that the exception is thrown here.
So with PHP Unity, the annotations in your doc block can be used to tell it to do certain things.
Yeah, and from what you were saying before, for this one, you could have a separate test, function test,
It doesn't matter.
original string. It could be a PHP exception. It could be a custom exception you made. You just tell it what class you want. So it, back to your original question. Now that I understand what you were asking, if you do a test, original string is returned if delimiter not found. That's basically what you're doing. So, and actually in this test, you could assert same the original string. So we would want to call this test does not split if delimiter not found. That might be a better name. So if our string is hello world, we can assert not same hello world if we explode based on, say, the pipe. And then that'll pass because when you explode this using the pipe, it's not gonna give you this. Yeah. So like you said, every assert has an assert not. Most of them, at least. Any others? No? Okay, well, I didn't see any, I don't think I saw any issues with the recording, so if this turned out fine, well, once I can get it on YouTube, I'll post a link on the Meetup so you can refer back, or anybody who missed it can check it out. So, thank you.